electrical model, we completed 4 circuits. The first was the basic light switch. This is the most common switch seen in houses. The electric current is carried from the power supply to the switch and then to the light fixture. For this circuit, we need the following items. About 6 feet of 14-2 wire cut into 3-foot lengths, a rectangular box, single pull switch, a red Robertson screwdriver, a green Robertson screwdriver, a wire ripper, a wire stripper, needle nose pliers, combination side cutting pliers, wire connectors, light fixture, light bulb, and power source. We're first going to take our 3-foot length of 14-2 wire and we're going to rip back the outer casing on about 6 inches of the wire. This gives us enough wire to work with inside of the box so that our hands are not too far down inside of the box. We then take the wire stripper and at the gauge size 14, because we're using 14-2 wire, we're going to strip about 1 inch off the end of the wire. We then feed the wire into the one end of the box and pull through so that the wire is clamped down by the metal piece on the inside. The wires that are sticking up, we can then use our needle nose pliers to create what we call a pigtail on the grounding wire. The grounding wire on 14-2 wire is the copper colored unwrapped wire. This can be wrapped around the grounding pin inside of the box. The black wire coming from the power source is then connected to the gold pin on the light switch. We'll then take the other length of 14-2 wire and do the same stripping process on both ends of this time. 6 inches of the outer casing and 1 inch on the inner ones. We'll use the pigtail method using our needle nose pliers to create a curve around the screw and connect the black wire again to the side of the switch. This is fed out of the box through the opposite side. That wire is then fed into the octagon box for the light fixture. The white wires for both of these are connected using a cap. Yellow caps are used when you're connecting 2 14-gauge wires. They can be pinched at the top and turned to create a spiral, and the cap can be screwed on until it's tight. When this happens, a connection is formed. The white wire is fed to the light colored screw on the light fixture. The black wire is then fed to the gold colored screw on the light fixture, and your circuit is complete. You can connect the black and the white wires to the power source and test it. The second circuit that we completed during the electrical model was the wall outlet. This is the traditional 2 plug-in outlet that is found in many places around your home. Power is ran directly from the supply to the outlet where you can then plug in many things. For this circuit, we need the following items. About 3 feet of 14-2 wire, a rectangular box, receptacle, a red Robertson screwdriver, a green Robertson screwdriver, a wire ripper, a wire stripper, needle nose pliers, combination side cutting pliers, wire connectors, and a power source. Wiring of the wall outlets is similar to the way that the light switch was wired. We have 2 strands of 3-foot 14-2 wire. 14-2 wire is run from the power source into the first box, and there's a second piece of 14-2 wire ran from the first box into the second box. The piece of 14-2 wire that's run into the second box is where we're going to start. The black wire is ran to the gold pin. The white wire is ran to the silver pin, and the grounding wire is ran to the green pin or to the grounding pin inside of the box. This is then pushed down inside of the box, and the second outlet box is complete. We move on to the first outlet box. We connect the black wire that ran from the second box to the black wire coming from the power source to a short little black wire going to this outlet. It connects to the gold pin. The grounding wire from the power source connected to the grounding wire from the second outlet is connected to the grounding pin on the outlet. The three white wires are connected in a similar way. This is then put inside of the box and the power source is tested. The third circuit we chose to complete during the electrical model was the light switch outlet circuit. For this circuit, we need the following things: about 9 feet of 14-2 wire cut into 3-foot lengths, 2 rectangular boxes, a single pole switch, a receptacle, a red Robertson screwdriver, a green Robertson screwdriver, a wire ripper, a wire stripper, needle nose pliers, combination side cutting pliers, wire connectors, light fixture, light bulb, and a power source. This circuit has the power source wired directly to the light fixture. From the light fixture, there's a connection made to both the light switch and the outlet. Because the outlet and the light switch are ran separately through the light fixture, the light switch does not turn on and off the outlet when the switch is turned. For this circuit, we can start at either the outlet or the switch. On the outlet side, the white wire is connected to the silver screw. The black wire is connected to the gold screw, and the grounding wire is either connected to the green screw or to the grounding pin inside of the box. The outlet is then put down inside the box and we can move on to the other. When we look at the switch side, the black wire is connected to the gold pin on top. The white wire, painted black, as it's acting as power, is connected to the lower pin on the switch. The grounding wire is connected to the green screw or to the grounding pin inside of the box. These wires are both ran out of the box to the octagon box at the top where your light fixture is connected. Your grounding wires are all connected together using a cap. Your white wires are all connected together using a cap. And your black wire from your power supply, your black wire from your outlet, and your white wire, which is painted black, from your light switch are all connected using a cap. Your black wire from your light switch and your white wire coming from your receptacle are both connected to the light fixture. Then a test is ran. The fourth circuit that we completed during our electrical model is the double pole light switch. This is often seen in your house, often in a kitchen where you want to have light switches in multiple locations. Both switches act on the same light source or the same light fixture. Power is ran through one light switch to the light fixture, then to the other switch. For this circuit, we need the following items: about 9 feet of 14-3 wire cut into 3-foot lengths, 2 rectangular boxes, 2 double pole switches, a red Robertson screwdriver, a green Robertson screwdriver, a wire ripper, a wire stripper, needle nose pliers, combination side cutting pliers, wire connectors, light fixture, light bulb, and a power source. This circuit is a little different as it uses 14-3 wire instead of 14-2 wire. Coming from the power supply, we have 14-2 wire. The white wire from the 14-2 is attached to the white wire coming through the other side of the receptacle box going to the fixture. The grounding wire from your power supply, from your light fixture, and your switch are all grounded to the box. Your red wire is ran from your switch to the light fixture. You can see in the diagram that the red wire runs right through the light fixture to the other switch. Looking at the other switch, the red wire ran back to the light fixture connected to the other red wire. We then look at the grounding wire. The grounding wire from your light fixture is grounded to the grounding pin on your light switch and grounded to the box. For this, your black wire is fed from your gold screw to the light bulb. The white wire, which in this case is painted black, carries power. It's brought back to the light fixture and connected to the black wire coming from the power supply and the other switch. When all of the connections are made and we have no loose wires, we can test our circuit.